Hello, this is Tahsin from Roots of Unity. Last couple of videos we've been looking into matrix addition, subtraction and multiplication, and now it's time to look into the next arithmetic operation, division. However, matrices can't be divided like that. Matrices can't be divided, but there is a workaround way. Let's consider dividing 8 by 2 here. 8 divided by 2. This can be rewritten as 8 by 2, and then this can be rewritten as 8 multiplied by 1 by 2, and this can be rewritten as 8 multiplied by 2 to the power minus 1, which is 8 multiplied by 2 inverse. Just like how numbers can be inversed, matrices can also be inversed, and we can use the inverse form of the matrix to achieve a similar result as to division. So let's say we multiply 8 with 2 to get 16, and then we divide 16 with 2. We multiply 16 with the inverse of 2 to get 8 back. So you see, if we have two numbers and then we multiply them and then get the product, and then multiply that product with the inverse of the second number, we get the first number back. This is the case with numbers. Now let's see whether this holds true, whether this trend holds true with matrices as well. So let's say we have these two matrices and we multiply them to get the result as this, and then if we take this and multiply it with the inverse of this matrix, we get the first matrix back. So you see that trend also holds true with matrices, that we can achieve a similar result of dividing matrices, of dividing this matrix to this matrix by multiplying this matrix with the inverse of this matrix. The definition for inverse matrix is such that if we multiply a matrix A with its inverse, we get the identity matrix as the result. Let's look at an example. Let's say we have a matrix 1 2 3 4 and we multiply it with its inverse, which is minus 2 1 3 by 2 minus half. We get the identity matrix as its result. Now let's go back to the previous example and see what happened there. Here we can say that this is A, this is B, and then we can write this down as AB. A multiplied by B equals AB, and then this is AB, and this is the inverse of B. So if we multiply AB with B, we get AB times B inverse. This B and this B is adjacent, and then we can multiply these two together. We get AI, I for identity matrix, and then we multiply A to identity matrix to get A. Now that we've seen what inverse matrices are, it's time to question about its limitations. Previously we've seen that you can't add any matrix to any matrix. There are restrictions on it. You can't also multiply any matrix to any matrix. There are restrictions on it. Now it brings us to the question whether there are restrictions on inversing a matrix. Do all matrices have an inverse, or are there restrictions on inversing matrices as well? The answer is yes, there are restrictions on it. You can't inverse any and every matrix you see. The requirements for inversing a matrix is that the matrix has to be a square matrix, which means that the matrix has to have the same number of rows and the same number of columns. So it has to be a 2 by 2 matrix, or a 3 by 3, or a 4 by 4, or a 6 by 6 matrix, and so on. And the second requirement is that it must be a non-zero a matrix with a non-zero determinant. What do we mean by a non-zero determinant? Heck, what do we mean by a determinant? The determinant of a matrix is a scalar value determined from the matrix itself. Let's say we have a matrix A, then we denote the determinant as det A. And for 2 by 2 matrices, we find out the determinant using this formula. If the matrix is A, B, C, D, then the determinant of A is equals to modulus of the matrix is equals to AD minus CB. This right here is the formula for the determinant of a matrix if the matrix is defined as such, A, B, C, D. Now let's look at an example. Let's say a matrix A is defined as 1 2 3 4. Then the determinant of A, det A, equals to modulus of the matrix equals to 1 times 4 minus 3 times 2, or 2 times 3 is the same thing. giving us minus 2 as the result, and this is the determinant of the matrix A, which is 1 2 3 4. So what we meant by a matrix cannot have a non-zero determinant if we are to find out its inverse is that the value of determinant, the determinant of the matrix, this value cannot be 0. This value, the det of A or det of whatever matrix you're doing, can be 1 2 3 4, any positive number, any negative number, any real number, or even any complex number. It can be anything, but it can't be 0. If it's 0, then you cannot have an inverse. So now let's look at the formula for the inverse of a matrix. For 2 by 2 matrices, the formula of the inverse matrix is this. If we define a matrix A such as A, B, C, D, then the inverse of the matrix A is equals to 1 by the determinant of A multiplied by D minus B minus C A. You see these two cells have switched the places, and we've multiplied a minus to B and a minus to C. So if we simplify this, then we will get 1 by AD minus BC multiplied by D minus B minus C and A. Now let's look at an example. Let's say we define a matrix A as 1 2 3 4. Then the inverse of A is equals to 1 by the determinant, which is 1 multiplied by 4 minus 2 multiplied by 3, multiplied by, we switch the places up, we get 4 here, and then we get 1 here. And then we have negative 3 here, we multiply a negative sign here and a negative sign here, and we have negative 2 here. Now after simplification, we get 1 by minus 2 multiplied by 4 minus 2 minus 3 1. We can keep this this scalar quantity outside. We can keep this minus half outside, but we can also multiply together to get minus 2 1. 3 by 2 minus half. It's your choice. Both of these forms are correct and will be accepted as final answers. Now let's look at another question. Let's say we are given a matrix AB is equals to 19, 43, 22 and 50, and the matrix B is 1, 3, 2, 4, and we are asked to find out what the matrix A is. We can solve this problem by simply dividing AB with B. We can't divide AB with B directly, so we'll just multiply AB with B inverse. So the first step for us is to find out B inverse. So B inverse is equals to 1 by the determinant, which is 4 times 1 minus 2 times 3, multiplied by, switch these two places up, this is 4, this is 1, this is minus 2, and this is minus 3 here, and then we simplify it to get minus 2 1, 3 by 2 minus half. Now we have AB as this and B as this, B inverse as this. Now how do we get A from AB and B inverse? Which side do we multiply B inverse to? Is it the left side or is it the right side? We multiply it to the right side. It's because if we multiply it in the right side, then we have these two b's corresponding to each other, and then these two multiply off, and we are left with A. Now let's put AB here and B inverse here and do the actual multiplication. After multiplying this to this, we get A as 5 6 7 8, and A is the final result. Now let's look at another example. Let's say we're given A inverse, which is this, and we're asked to find out A. Well, it's quite simple. We just have to inverse A inverse to get A, because the inverse of A inverse is equals to A to the power minus 1 multiplied by minus 1 is equals to A to the power plus 1, which is equal to A. So therefore A is equal to the inverse of A inverse. So A is the inverse of this is equals to, after doing the calculations, we find out A is 1 2 3 4. Now let's look at another example. Let's say we have a matrix A which is given. A matrix A is given, and we are asked to find out A cube. We aren't actually going to do any calculation here, it's just a hypothetical question, and we're going to see how to solve it. So we can find out A cube by breaking down this term. We can break down A cube to A to the power minus 1, A inverse to the power 3, and this is A inverse into A inverse into A inverse. We can find out A inverse easily since we are given A, and then we just multiply A inverse to A inverse to A inverse 3 times, and then there it is. We get the result as A cube, A to the power minus 3, sorry. Now let's look at another hypothetical question. Let's say we're given A inverse and B inverse, and we're asked to find out AB whole inverse. We're not going to do any calculation here. We're just going to show how you find out AB inverse, how you solve questions like this. So to do this, you might think that AB inverse can be broken down to A inverse multiplied by B inverse, but that's not the case. Sorry. It's actually the other way around. AB inverse is actually equal to B inverse times A inverse. Yep, that's how it goes. And it's kind of it's actually a certain formula. You have to remember this, that if you have matrices here and there's an inverse, then it doesn't go like A inverse times B inverse. It goes the other way around. It goes like B inverse multiplied by A inverse. Let's see what happens if we have ABC inverse. If we have ABC inverse, this can be broken down as C inverse times B inverse times A inverse. What if we have ABCD whole inverse? Then it goes like D inverse times C inverse times B inverse times A inverse, and like that. That's gonna be all for today. Hope you liked the video. Next video we're gonna be looking into inverse matrices once again. Till then, stay tuned and stay curious. Signing off, Tahsin.